Okay, good morning to all. So we'll start today's session. I have not prepared a PPT, so we'll cover the topic from the book itself. So I'm going to present a screen. Look what is happening every time students are joining, and it is interrupting me. That's why I asked you in last lecture that join with the GP Gondia mail ID, which is given to you, so that it will not disturb the session. But still I think all of you are using your regular Gmail ID. So try to use GP Gondia Gmail ID which is given to you, so that it will not interrupt me a lot in between the session, or otherwise you join the session before start. So let me present the screen. Okay, is this screen visible?
Yes, sir.
Okay, so combinational logic design. Uh, we are at second unit. So we have covered first point, that is standard or canonical form for Boolean function, minterms and maxterms. So before going for simplification of logic circuit, uh, or by the way of sum of product or product of sum approach, we'll cover some of the things related to this canonical form of Boolean expression. So if you observe, basically we have two broad types or categories of digital circuit. One is combinational circuit and another is sequential circuit. So combinational circuit, so basically these two, combinational circuit and sequential circuits. Right now we are seeing combinational circuit, later on will see sequential circuit also. So the difference between combinational circuit and sequential circuit is, in combinational circuit the output depends, okay, output and it at any instant depends, okay, upon the present input, okay, at that time. Whereas in sequential circuit the output depends on the present as well as past inputs. Okay, so this is the basic difference between combinational circuit and sequential circuit. In combinational circuit, output at any instant of time depends on the input present at that instant of time. Means if I want to get the output right now, whatever inputs are applied currently, the output will be generated depending on that. Whereas in sequential circuit, the output generated will be depending on current input as well as past input. So this is the basic difference between combinational circuit and sequential circuit. One more thing is, if I want to design sequential circuit, its output depends on present input as well as past input. So I need to remember that past input. Okay, so for that I need a memory, because without memory you cannot remember, right? So that's why the sequential circuit is also needed memory element. Okay, the needed element is memory. Now the next is we can simplify Boolean functions with multiple techniques. So there are 4 techniques like this. Okay, algebraic method, Karnoff map technique, Wien-McCleskey method, and variable entered mapping method, VEM technique. So out of these 4, we have already seen algebraic method, where we have reduced or simplified the given Boolean expression into its simplified version. In this unit, we are going to see Karnoff map technique. Wien-McCleskey and variable entered mapping is not there in your curriculum, but if you are interested in that, you can see these two also. Basically, Wien-McCleskey method is there because Karnoff map technique has some limitations. Like we can only reduce 4 or 5 variables in Karnoff map. So if we have a equation with many variables, in that case, this Karnaugh map technique will be unsuitable, or it will not be able to reduce the equation. In that case, Wien-McCloskey method will help us to reduce the Boolean function or simplify the Boolean function. So we have seen algebraic method. In this unit, we are going to see Karnaugh map. Wien-McCloskey and BEM are not there in your curriculum. Now, standard representation of logic function we have seen in previous lecture, that is sum of product SOP and product of sum, that is POS. Okay. So the next point is these are all things are there in book, so you can go through it. These are nothing but a representation of equation in the gate forms. So we want to see next point, that is this converting a given equation into canonical SOP or
सर
canonical.
आपकी आवाज नहीं आ रही है.
Am I audible now?
आवाज नहीं आ रही सर.
Am I audible now?
Yes, sir. Yes, sir.
आ रही है बराबर आ रही है.
आप लोगों ने बहुत लेट बताया, बहुत कुछ तो कवर हो गया.
Oh, sir. सर आवाज आ रही है.
इसके पहले आ रही थी.
Yes, sir. सर नेटवर्क प्रॉब्लम आई थिंक.
अभी तक मैंने जितना बताया आवाज आ रही थी या नहीं?
यस सर, आ रही थी.
Okay, fine. So shall we continue forward or shall I repeat?
Sir, one time please repeat.
Okay, give me a minute. Okay, so combinational logics design is the topic which we are currently covering up. So, okay, as you see in the curriculum, first point we have covered. Second, simplification of logic circuit by way of sum of product and product of sum. This is the topic which we are supposed to see. Since I have not prepared the PPT for today's lecture, so I'm going to cover it with the help of book, that is Modern Digital Electronics by R.P. Jain. This is the book you have to refer. So basically, logic or digital circuits are divided into two broad categories. One is combinational circuit and another is sequential circuit. Right now we are going to see combinational circuit. Later on we will see sequential circuit. Now the difference between combinational circuit and sequential circuit is, in combinational circuit, output at any instant of time depends upon the input present at that instant of time. Means if I want output right now, it will depend on the input which is applied right now. Okay, it does not depend on the previous inputs or previous outputs. So combinational circuit output is depend on the present input, means whatever input applied right now at this instant. Whereas in sequential circuit, if I want output right now, the output will be dependent on current input, means whatever input is applied right now, as well as the previous inputs or outputs. So if I want previous input and output, then I need a memory to remember what was the previous input or output. So in sequential circuit, previous memory element is required for remembering the previous input or output. As in sequential circuit, current output depends on the present input as well as past input and output. So this is the basic difference between combinational circuit and sequential circuit. In combinational circuit, present output depends on the present input only, whereas in sequential circuit, present output depends on present input as well as past input or output. So this is the difference between combinational and sequential circuit. Most of the time, this needs to be remembered. So just have a clear uh, understanding of this combinational circuit and sequential circuit. Now, to simplify a given Boolean function, there are four methods. One is algebraic method. Okay, these are the four uh, methods by which we can simplify given Boolean function. Okay, so first one is algebraic method. Second one is Karnoff map technique. It is also known as K-map technique. Third is Quinn-McCleskey method, and fourth one is VEM technique. So out of these, first and second method are there in your curriculum, whereas third and fourth are not there in your curriculum. We have already covered algebraic method, where we have given the expression and we have simplified it, and we got the simplified version of a given expression. In this unit, we are going to see Karnoff map technique. And Quinn-McCleskey and VEM are not there in your curriculum. Still, I would like to tell you about Quinn-McCleskey. With the help of Karnoff map technique or K-map technique, we can reduce the expression with some limitation. The limitation is that with the help of Karnoff map, we can reduce up to maximum 4 or 5 or 6 variables. But if we have a bigger expression with more number of variables, then this Karnoff map technique will not help you to reduce the expression. In that case, Quinn-McCleskey method will come. You have to use. And what is there in Quinn-McCleskey and variable this VM technique that you can study. So next is standard representation of logic function. This also we have seen. So basically there are two standard representation. One is sum of product and another is product of sum. Sum of product means you have to take product first and then you have to add it. Okay, and product of sum means you have to take sum first and then you have to take a product. Can anyone tell me this expression is sum of product or product of sum? Which type it is?
Sum of product.
Any other answer? Anyone else? Why it is sum of product? Can you explain? Why you are saying this is sum of product?
Because the equations are shown logically.
Okay, so this is basically a product of sum, not sum of product. Why? The reason is this is product of sum. Okay, this one is product of sum, not sum of product. What I said that product of sum means you have to take sum first and then product. So if you observe this equation, what you will find that first of all sum is taken and then in bracket it is put and then multiplied. Means first of all, and how it will be executed? First sum will be executed. After that, the product will be taken between these two. Means first sum and then product. Means product of sum. So that's why this is product of sum expression, not sum of product. Got this?
Sir, please once again repeat explanation.
Okay, we have two forms. One is sum of product and product of sum. So give me a minute. I will show you with the example. Okay, let's take an example over here. I will just remove this. Okay, there are two forms. One is sum of product and second one is product of sum. So when I say sum of product means first of all we need to take product and later on we need to take sum of that, sum of product. So first of all you need to take product and then sum, and inverse of that will happen here. Here you have to take first sum and then you have to take product of that. Now, let me show you with the example. So here sum of product means I need to take first product like A, then B, then it can be C bar, any product you can take, and then you have to, okay, so you will have products like this, suppose A bar, B, and then again let us say B, C bar. Like this you have products. Now you have to take sum of that. So what we can do, we can add those, and add. So this is nothing but your sum of product. What we did, we have taken first product like this, and then we added those to get the sum of product. So this type of equation is called as sum of product. Now what happens in product of sum? In product of sum, we need to first take a sum. Okay, we need to take the sum. How to take the sum? A plus BC. Let us say this is one sum, and then let us say ABC plus, or ABC plus, let us say A. Like this you have to take the sum first, and then after that what you have to do, you have to take a product of this. The product of this will be, what you have to do, you have to put these things in bracket, and then you have to take the product. So such type of expression can be called as product of sum. Got it?
Yes, sir.
This is the difference basically. This is sum of product. First you have to take product and then you have to sum it, and this is product of sum. So you have to take first sum and then you have to multiply both the term or multiple terms. So this is called product of sum. So in basically in product of sum you will observe parentheses like this. Okay, so if parentheses are there, means this, mostly you will observe parentheses like this. So that indicates that this is product of sum. So if you observe here, what you are getting, first addition is done, means sum is done, and later on product is taken. So this is your product of sum. Got it?
Yes, sir.
Yes, sir.
Now next. Most of the time the questions are asked like this: convert a given expression into canonical SOP form. Now what is that equation? Give me a minute. हेलो, हाँ बोलते हैं, हाँ बोल. हो मला थोडं 10-15 मिनिटं लागेल, माझं एक लेक्चर सुरू आहे, ते मी फिनिश करून येतो. 15 मिनिटात येतो मी तिथे. Hello, sorry for disturbance. So Okay, so such type of questions may come in exam that convert the given expression into canonical SOP form. So basically, what is canonical SOP form? Canonical SOP form is nothing but you have to uh, give me a minute. Okay, so canonical SOP form means you have to represent the given expression into uh, multiple what we can say max terms. Now minterm and max term we have seen. So let me show you minterm and max term that we have covered in last lecture also, means previous lecture also. So let me show you the minterm and max term so that it will be easier for you. Is my screen visible to all of you?
Yes, sir.
Sir, yes, sir, visible.
Yes, sir.
Yes, sir. Yes,
हाँ,
yes, sir.
Yes, sir.
हाजले का भी फोन आया था, मैं जा रहा हूँ 10 मिनट में, उसको बताया मैं 15 मिनट, और मैंने उसको बताया मेरा लेक्चर चालू बोला 10-15 मिनट के बाद. Okay, so minterm and maxterm you have to understand, which we have already covered. So minterm is this A B bar C, A B bar C bar, A B C. These are nothing but your minterms. Now, how many minterms can be there? Suppose I have a 3 variable like this. Okay, let me show you. Suppose I have 3 variables like this: A, then B, and then C. Suppose I have these 3 variables. Suppose I have 3 variables like this, A, B, and C. What can happen? I can have different values for this, like this. I can have different combinations like this: 0, 0, 0, 0, 0, 1, then 0, 1, 0. Next is 0, 1, 1, 1. Next one is 1, 0, 0. Next one is 1, 0, 1. Next is 1, 1, 0. And last one is 1, 1, 1. So like this, I can have 8 different combinations. Let me reduce the spacing. Okay, so I can have different combinations like this, right? All of you are aware about this, correct?
Yes, sir.
So
Yes, sir.
in sum of product we can have minterms, okay, and in product of sum we can have max terms, okay. So minterms in sum of product, okay, and max terms in product of sum. So the minterms can be written like this. For 0, 0, 0, it can be A bar, B bar, C bar, or for 0, 0, 1, it is A bar, B bar, C. Sorry, for 0, 1, 0, it can be A bar, B, C bar. For 0, 1, 1, it is A bar, B, C. For 1, 0, 0, it is A, B bar, C bar. For 1, 0, 1, it is A, B bar, C. For 0, I am writing bar. For 1, I am writing normal. Okay. Then for 1, 1, 0, it is A, B, C bar. For 1, 1, 1, it is A, B, C. So if you have, if you write down the sum of product form in with the help of these min terms, then these are called as canonical SOP form. Okay, you can, then it will be canonical SOP form. See, in the similar fashion, if you want to write down max terms, it will be like this. Okay, this is min term. I'll reduce this font size, and similarly you can have max terms. Max terms, which is nothing but your POS, product of sum, which can be written like this. What? How it can be written? A,
ABC
plus
B
B
plus B plus
plus C. Okay, A plus B plus C. In max terms, what happens? The expressions are written for 0, it is written normal, and for 1, it is written bar. This is the difference between min term and max term. Similarly, you can go for this. So this becomes A plus B plus C bar. Okay, because it is 1. C is 1. For here, you can write on A plus B bar
plus C.
C. Here you can write down A
plus B bar plus C bar
plus C bar. Similarly, you can write down for this A bar
plus
plus B
plus
C. Similarly, you can write down A bar
plus B
B
plus C
C bar. Okay, and then for this A bar
A plus
B bar plus
B
C
plus C
and for this you can write down A bar
A bar plus D bar
plus B bar plus C bar.
plus C bar.
C. Okay,
Yes, sir.
this is the way min terms and max terms are mentioned. And if you are using these min terms or max terms, then you can write down it in canonical form, either sum of product or product of sum. So the question is, here this equation 5.3 is given. That equation is this. This is the equation. AB plus AC bar plus BC. What is expected that we need to write down this AB plus AC bar plus BC in canonical sum of product form, SOP form. Okay, AB plus AC bar plus BC. So what we want to do, I'll use a minute. Okay. So I want to write down that what is that expression? AB plus AC bar plus BC. I want to write down this expression. Now, can anyone tell me whether this is in canonical form or not? Huh? This is not in canonical form because in this expression C is missing, in this B is missing, in this A is missing. So if terms are not there, means this is not in canonical form. So we need to convert it into canonical form. Now how to convert it? You can do AB. Now whatever term is missing, you have to write down C plus C bar. Since C is missing, I'm writing down C plus C bar. Next, A, C bar. B is missing, so what I can do? B plus B.
B plus B bar.
Similarly, here BC, A is missing, so what I can say? A plus
A plus A bar.
A bar.
A bar.
Right? Now we can simplify this. So if I simplify, what I will get? ABC plus ABC bar plus ABC bar plus AB bar C bar plus ABC plus A bar BC. Right? Now if you observe, ABC is 2 times, so I can mention it only for 1 time, plus ABC bar is also 2 times, correct? Yes or
Yes,
no?
sir.
So I can mention it ABC bar plus AB bar C bar is single time, so I'll write down that single time, A B bar C bar plus then A bar BC is single, right? So now if you observe this ABC, AB bar, ABC bar, A bar, AB bar, C bar, A bar, BC, these are nothing but this canonic min terms, right? So if you, now this is the canonical sum of product. This is nothing but your canonical sum of product. That is shown over here. Here, look, ABC plus ABC bar, ABC plus ABC bar, AB bar C bar, A bar BC. Got it? All of you got this?
Yes, sir.
So like this we can convert the given expression into canonical sum of product. Similarly, you can convert the given expression into canonical product of sum form. Here what we did, we have multiplied the sum form. If you want to convert into product of sum, you have to add multiplication. Look at this, like this. You have to add C bar. Got it? So like this you can do it. So try it at home, and we'll meet it in next lecture, and we'll complete it. Can you do it?
Yes, sir.
Yes, sir. We tried.
Huh?
Yes, sir.
Okay. So try it at home, and
Yes, sir.
we'll see it in next lecture, because I have a meeting at collector office, so I need to go urgently.
Yes,
So
sir.
we'll stop over here. Thank you all. And if you have any queries, we will take it in next lecture. Okay.
Thank you,